Alright guys, today we're looking at how to factor expressions that have two variables in there. Okay, so we have both x's and y's in the same expression. So when you look at this expression, where you've got an x squared, your middle coefficient is now attached to an x and a y, and you've got a y squared at the end, try to think for a second and pause if you need to. Where could something like this have come from? Well, hopefully what you realized is that we need two x's to get x squared, and we need two y's to get y squared. So in reality, they're going to look very similar to what we had before. Now there might be some numbers in one or more of these places, but it's going to look very similar to what we had before, except instead of just having this, where we don't have anything else, it's just like 3x plus 2 and 2x minus 3, we have y's in there as well. So the real question now is, how do we factor these guys? And I'm going to make life a little bit easy on you. It's really the same. The y's are almost an afterthought as far as our process goes. Okay, so basically what you're going to have to do is you're going to have to just either the y's are going to tag along for the ride, or they're just going to be thrown in there at the end to make it work with actual y's in there. But really, your methods are going to be the same. So you don't have to learn any new methods. You just have to just be able to recognize which method you're supposed to use when there's a y in there. So these are two polynomials in C that are very comparable. One is the same as the other, except one has an xy term in the middle and a y squared term at the end. So think about how you would factor this. Well, this is one of our easy shortcut ones. You'd be looking for numbers that multiply to -4 and add to +3. That would be 4 and -3. X plus 4, 4 and -1. X plus 4, x minus 1. So how do you do this differently with the y's? All you do is write the exact same thing, except we need y's. Y, y. Now that 1 becomes unnecessary, so I'm going to get rid of it. That's really it, guys. All you got to do is throw that y in there. It's really a throw in at the end. Go ahead and check if you like, but it works out really great. We get x squared minus xy plus 4xy. That's our plus 3xy minus 4y squared. It works. So you just have to be able to recognize which one you're dealing with, even when you see the y's in there. So try C. Everybody try C. Now you got to make a change because I goofed up on this one. Change that middle coefficient to a 9. Otherwise, it's not going to really work out too well. Change that middle coefficient to a 9 on both of them. But then go ahead and try D. Try D. Pause and come back. Okay, so you could have used splitting the middle term. You could have used brute force. You could have used box method. I don't really care. I'm going to use brute force because for me this is easy. This is a good one for brute force because you know you've got to have 2x and x and 2 plus signs. There's a very limited number of ways you can do 9. So you can do 3 and 3, or 1 and 9, or 9 and 1. Those are your only options. I'm going to try 3 and 3 because that seems to be the obvious one. Won't make anything too big or too small. And sure enough, that works. That gets me 2x squared plus 6x plus 3x. There's my 9x plus 9. So now when I want to do the same thing with y's, I just do 2x plus 3y and x plus 3y. So guys, there's really no difference. You could do difference of squares rule with this. When we eventually get to sum and difference of cubes rule, you can do it with this. Having the extra variable in there is not really that big a deal, as long as you've got it in this format where it's one variable squared and the other one squared at the end, and then you've got a nice simple combination of the two in the middle. And if you're unsure whether it works out, try doing it one of the normal ways that we've done and just throwing another variable in there, but then just make sure to check your work. And checking your work can help out a lot there. That's it for this one. Make sure you go on and look at B, because there we're going to talk about the all-important greatest common factor.